Okay, class. So today's objective is, what if there are variables on both sides of the equal sign? How do we solve for that? Many of you have shown me that you kind of understand this, which is great. All you are doing, you are combining like terms. Okay, you're combining like terms, just as if you had 3x plus 2y minus 4x, you would combine 3x with negative 4x and you get negative 1x or negative x plus 2y. Okay, it's very much the same thing, but since now you are dealing with an equal sign, if you need to combine a term with something on the other side, then you have to do the opposite in order to get to that side. So if you look at this example on the bottom here, 6x equals 4x plus 24, okay? I know the work is already here, but let's just pretend it's not there. I want to combine 6x with 4x. And since 6x is already almost by itself, I'm just going to bring the 4x over there. And so I need to do the opposite of the 4x for me to combine with the 6x. And then I end up with 2x is equal to 24. And this ends up being the same thing. So 2x equals 24. Now that I just have one variable that I'm dealing with, divide both sides by 2, and I get x equals 12. So make sure that you end up with one variable on one side, combine like terms, but if you have to combine on the other side, then you just do the opposite. Try these problems on your own. So hopefully you figured out, I want to combine the 4t and the 6t, and since 4t is almost already by itself, I'm just going to add the 6t, do the opposite to the other side, and so I get 4t plus 6t is 10t is equal to 50, and then again I have a one-step equation, and t is equal to 5. Pause the video and try to see if you can do number 2 on your own as well. Now, with fractions, nothing's different. Just instead of looking at it as two numbers, it's just one number. So 3/4 is one number and 8/5 is one number. I want to combine the 3/4 with the 8/5, so I need to add 8/5 x on both sides. Now, how do you add fractions? Now that goes back to way back in 5th grade, 4th grade when you add fractions. You got to get like the same denominators, common denominators, so 4 and 5. This is going to change to 20 in the denominator. And in order for me to change this top one to 20, I have to multiply by 5, which means I multiply by 5 in the numerator to get 15 over 20, it's x. This one I need to multiply by 4, and I get 32 over 20x. And so now I'm actually adding 15 and 32 to get 47 over 20x. And then, since you have a fraction being multiplied by a variable, you multiply by the reciprocal on both sides. And you get x is equal to 80 over 47ths. Okay, very ugly answer. I know we haven't dealt with fractions in quite a while, but it's the same. Okay, why don't you go ahead and try the bottom 3 on the next page. Okay, so this first one, you have to distribute first before you, and then combine, and before you can really do anything. So distribute this 4. And so you get 4r minus 36 plus 2 is equal to 12r plus 14. And you'll actually notice on the left side that you can combine the negative 36 and the 2 before you move on. So you get 4r minus 34 is equal to 12r plus 14. Now, from here, it doesn't really matter which one you want to start first. You just need to combine the like terms. So I know that negative 34 and 14 I would eventually want to combine, and the 12r and the 4r I eventually want to combine. And so maybe I'll just deal with the negative 34 and the 14. So I'm going to do the opposite of the negative 34. And so I have 4r is equal to 12r plus 48. And I want to combine the 4r and the 12r. And since the 4r is already pretty close to being by itself, I'm just going to subtract 12r on both sides. And then I get negative 8r is equal to 48. And then I'm down to dividing both sides by negative 8. And so r is equal to negative 6. So that's a nice situation where I get r by itself. If you try number 4, you got to distribute first. And so you distribute the 3 and the 2 on this side. Make a big wall here so that I get that. And again, you'll notice on the left side you can combine your 3x and your minus x. And so that gives me... Now, you'll kind of notice that if I were to combine the 2x and the 2x, that means I got to do the opposite, right, of one of them. So let's say I want to do the opposite of this 2x here and bring it over here, so minus 2x. And this disappears on the left side, and you end up with 6 is equal to, and actually this disappears on the right side too. You get 6 equal 2. Your variables disappear. Now don't freak out, that's okay. I got 6 equals 2, and I have to ask myself, is it a true or false statement? Well, is it true or false? Is 6 the same thing as 2? No, it's not true. So since it's not true, when the variables disappear, and there's nothing left and you have a false statement, this is something called a no solution. Well, if you don't want to write the words, this is the symbol for no solution. Okay? So number 5, actually, number 5 is pretty similar in that way. So again, I'm just going to distribute what I need to distribute, and then I can simplify some things. So that's what I get when I distribute, and then I'm going to simplify the terms here on the left side and the terms here on the right side. And you're starting to think things are a little bit eerie because the left side and the right side are exactly the same. But let's kind of continue on anyway. If I do the opposite of this 6y and do that over here, that ends up canceling. And so I have 19 is equal to 19. Again, the variables have disappeared and they're gone. And again, the question is this a true statement or is it a false statement? The last time we had 6 is equal to 2, and that was false. When it is false, then we conclude that there is no solution. When it is true, in this case, this is true, then instead of no solution, that means there are an infinite amount of solutions. And that's our conclusion. What that means is it doesn't matter what y is equal to. Y could equal 3. Y could equal negative 1,000. And if you plug that into this whole equation from the beginning, you'll always get a true statement. And so there's not just one unique solution. So there are 3 different cases. Case number 1 is if you end up with x actually equaling something. So that's one solution. There's only one number that fits into that equation and works. Case number 2, you end up getting a false statement and there's actually no solution, meaning there's no number that you can plug into the equation to satisfy that equation, to make it even, to make it equal to each other. And then the last case is infinitely many solutions. That's the infinity symbol. And that's when you end up with a true statement, again, when the variables just kind of disappear. That, again, means that any number that goes into the variable, you will get a true statement. If any part of this video was confusing, pause, rewind, or ask a classmate, and hopefully they can clarify with one another. I'll come back the next day and clarify with you.